before we do Lab 6, we're going to take you through Lab 5 and take you through debugging and show you how to use the debug tools that are there. Now, if this is the screen that you get, you'll have to go to View, Solution Explorer, so you can bring up stuff that's a little bit more identifiable. Now you can click on here, Lab 4, and if you double click on that, that brings up what you had here last time. We can double click on Lab 5, bring this up, and right now we have no solution sitting there on source file, so we're going to say Add Existing Item, and I believe it was Lab 5A. So let's bring up 5A and double click here, and we'll go full screen so you can see everything clearly. And once we have all this stuff set up, one of the things that you're going to find, let's do that again, Shift Alt Enter, and once we have all this stuff set up, what we need to do is set something called a breakpoint. What is a breakpoint? Well, a breakpoint is a place where you run your program to, and then it drops out and continues on from that point. Now, our programs start here in main, and the first real executable line of code is explained. So let's start it here, and all we have to do is move over into this area here and click. And once you click with the left mouse button, what you're going to see is a red ball, and that's your breakpoint. Now you can set other breakpoints. You can click down here, you click on it again, it removes it. Very simple to use. So what we're going to do is we're just going to run our code as we normally do. We're just going to hit F5. So when we hit F5, it's going to compile and do all of its normal stuff. But then what it's going to do is when it's finished and does its linking, it's going to run your code, and you're going to see a little flash of your DOS output screen here in a second. And what that means is that, there we go, it just flashed. Now it hasn't gone anywhere. Now notice we've got an arrow here that says that's the instruction that it's about to execute. It hasn't executed it yet. If we hold down the Alt key and Tab, we can see our output screen, and our output screen here is black. It's just initialized it. That's all it's done, but it's there, and we can Alt Tab back to here and see what's going on. So one of the things we're going to find, and let's take a look up at the top here, there's something called Step Into. And what we want to do is just click on that. That's our Step Into button up here at the top. And that's going to allow us to step through our code step by step and see what's going on. So let's see how that works. If we hover over this button, what it says is this is the next statement that will be executed, not the one that has been executed. And that's an important thing to remember, that it's always showing what's going to be done next, what isn't done right at this point. It says to change which statement is executed next, drag the arrow. This may have unintended consequences. We're not going to do that. We're just going to follow through with standard procedure, just realizing that this will be the next statement that will be executed. Now we're going to go back up here to the Step Into button. We're just going to click on it and keep clicking it and look around and see what goes on as we click. So let's click on it, and notice what it's done, which is quite interesting, is now our next statement down here, if we take a look, our next statement here where the arrow is saying is the start of our explain function, because we were just executing the explain function call. So it's called out to this function, and it's actually transfer control here. It hasn't started yet, so let's just Step Into. Now it's about to, but it hasn't cleared the screen yet. It's about to, but hasn't put up the put string. And if you don't believe me, let's switch over. Let's Alt Tab back over here to our DOS output screen, and we can see that there's no text on there yet. And if we click back here, we can see it's about to do that. So if we do a Step Into, then right now if we Alt Tab back, it's actually put that line of code on there. You will be asked. Now it's about to do the root of, but it hasn't done that yet. So let's just keep stepping into. So we'll step into. Notice over here, and let me just bring this up, that if any time that we want to stop this process of debugging, we just have to hit the Stop Debugging button. We won't do that right now, but we can do that later. Step Into and Step Into. So when we're finally finished, it's going to hit this bottom bracket, start at the top bracket of the code, bottom bracket, and it should have all 3 lines of code up there. So let's just take a quick look, and indeed we see that's what's happened. Now if we step into one more time, it's hit the bottom of the explain function. So what does it do? It returns right back to the very next executable line of code after the explain function. So the explain function executes completely, and then it automatically, and this is a beauty of functions, it returns, as soon as it finishes the function, it returns right back to the very next line. Now it's not executed this line yet because this is the next statement. So if we hit this, it's now going to say printf input your number, and it's prompting us for our input. Now let's take a look back here. And one other thing we can do is we can just hover over Bob, and if we hover over Bob, it shows us, now we can't see it unfortunately in the magnifying glass, but we can double click, right mouse click on the thing, and go up here to where it says add watch. Now what add watch does is it, let's do that again, right mouse click, add watch, just a little pair of glasses, and what we're going to see down here at the bottom is Bob, the actual watch 1. This is our first variable, and we can see the contents of the variable, and right now Bob has got 1 point, look at this, 1.0 minus 1.073741.8 times 10 to the plus 8. And what is that saying? That's saying Bob has got garbage in it, because Bob has not gotten anything coming out of this function yet, and any variables that have been declared, as Bob has been declared up here, let's take a look up here, Bob has been declared. When you say float Bob, it doesn't put a number in. What it does is it assigns it a place in random access memory, and random access memory has random crap in it until you actually put something in. So Sally's the same way. So let's take a look at Sally. Let's go down here. We'll double click on Sally, right mouse click, and say add watch. And if we take a look down at Sally here at the bottom, Sally, there's our second variable that we're watching, seeing what's inside it. And right now Sally's got, again, practically it has got the same value, some default crap in there. It could be any random number at all, but it just happens to have that in there. Now let's slide down. Is there anything else? No, there's nothing else. We got Bob and Sally covered here. So let's go and say step into, and notice what it's going to do. Bob equals get value, so it should be going to the get value function. So let's click on our step into, and indeed it does come down here, and let's step into again, and then let's take a look at Fred. Let's right mouse click and say add watch, and Fred right now, if we take a look, Fred is going to have similar stuff in it. Notice these other two variables, Bob and Sally, are ghosted. Why are they ghosted? Because Bob and Sally are in main. They are not in the get value function. So as you go from function to function, only the variables that are in that function are going to be available to you. All the other ones are completely unavailable. So let's go back, and it's got some default crap in it as well. Now it's about to do the flush. Let's let it do that, and it's about to do the scan. Now as soon as we click on the scan, it actually brings up our DOS screen. So if we type in 27, for instance, and hit enter, and then go back to here, notice what we have now for Fred down here at the bottom. Fred has now got the value 27 that we typed in from the keyboard, and it's about to return that back. Now notice right now, before we go back, both Bob and Sally have default crap in them. So let's watch what happens when we go back. So it's about to return, so we hit the step into button, hits the bottom bracket, and it goes back up here. Now it hasn't executed the Bob equals yet, so Bob has still got crap in it, but if we step one more time, notice what's happened here. And let's take a look at the bottom, because this is very important stuff. It says Bob has now got 27. And where did it get it? Got it from Fred, because Fred tossed his bucket up, Bob caught it, Bob tossed a 27, or Fred, sorry, tossed a 27 from his bucket up, Bob caught it, and now that transfer has been made. So at this point, when we look at it, Bob is going to have 27. Sally still got crap, and let's see what's going to happen when we go ahead, step into, and now we're into the cubic root function. And let's step one more time, and let's take a look at what X has got in it. Now X is going to have, if we looked at it, would have crap in it, and then its X is going to be 1/3. So we could take a look at that. And so let's double click on X, right mouse click, and add a watch. And right now it's got garbage in it, but as soon as we step into and look at it, we'll see that that number that's there isn't perfect, but it's fairly close. We can find that X is going to be 0.333334. So it should be 0.3 to infinity, but that's as close as you can get. So this is called round off error, but we'll deal with that later. Right now it's about to do, but hasn't done, it's going to do the power function, and it's going to return back to the calling thing here, 27 to the 1/3 power. So let's double click on num and take a look at that. We can add a watch here, and we can see that indeed num has got the number that was passed in. Now let's slide up here a bit, And the number that we put in here originally, if we look, Bob had 27, and we can see Bob is ghosted down here because that was done before. Bob has got a 27. So if we look up here, the 27 was passed into here, and the 27 has been picked up by num. So what was in Bob was 27 is now a num. We can see 27 here and 27 here, so it's actually done that transfer. So if let's take a look, it's going to redo the return. So let's hit the step into button. Now it's jumped into our math.h function, as you can see here. So let's close that. And then let's see what it's going to step into next. It's going to keep going on into that a little bit, and then it comes back and it says, okay, now I've got everything I need in the math function, so let's step into it, and it's going to hit the bottom bracket, and it's going to return back up to Sally. Now Sally, if we look down at the bottom here, Sally, because it hasn't executed that statement yet, Sally has still got garbage. But what we're going to find, and guess what it's going to do? Can you guess? When we hit step into, the value that was returned was, let's see, Sally is now 3, because it's actually calculated the cubic root of 27 and come up with Sally as the value of 3. So you can see how things are being done here. And right now we've seen everything except the display Bob and Sally. And let's take a look. And what's going to happen here, well, now we've got a watch here for the X. Let's also double click here, right mouse click and say add watch, and it's going to say error symbol Y not found because it's not in this function yet. So if we go ahead, it's in the function now, and notice X that's had the value passed in because it passed in Bob. What was in Bob? Bob was 27, and so 27 is now X. You can see X down here. It's hard to see, but let's bring up our magnifier. X is 27. There's X is 27 and Y is 3. So it actually passes those numbers in. And let's hit this again, or step into, and it's about to do the printf, and it's now done the printf. Let's go back. Let's Alt Tab back to our output screen, and you can see all the stuff that came up on the screen originally is there, but now we get a better idea of why it's there and how all this stuff works. Now to finish, as we said at the start, there's a couple things we have to do. Let's go back up here, and we'll just hit the stop debugging button because we've seen pretty much everything we want. We'll stop debugging, and the other thing that we have to do is go down here and click on this ball so that the next time we run our program, it's just going to run normally and not be going through this debug thing. And let's also close the math.h file. So that is a quick run through of debugging your code using our program of Visual Studio Express. So now that we've done that, it's time to get started on Lab 7. Or sorry, Lab 6. I'm jumping ahead of myself again. Okay, now that we've gone from we want to get to Lab 6, here's what we're going to do. We're going to we're going to Shift Alt Enter to get back here. We're going to right mouse click on Lab 5, and we're going to say remove. And Lab 5 will be removed. Okay. Shebang. Now, next thing we want to do is we want to start a new project. So we're going to say is File, New, Project, and we're going to say OK, and we're going to make this Lab 6. And we're going to hit Enter, and it's going to do all of its normal stuff that it does. And once it's got that going, oh, it's a little busy. So once we've got that done, we're going to do the same sort of stuff as we normally do. We're going to go to Application Setting, say Empty Project, and say Finish. And current solution will be closed. Nope. Alright. So we'll say no to that. And we'll have our Lab 6 solution coming up. So here we are, Lab 6. Now we haven't created anything yet. Now let's see what it is we have to do. So let's Alt-Tab, and hopefully at this point you've brought up Internet Explorer. And in Internet Explorer we should find, come on, there we go, whoops. We now have Lab 6 defines and header files. So we're going to click on that. And once we click on that, eventually, come on, it should come up and generate the PDF file and say yes to non-secure items. I'm not sure why it does that. How secure can it be? Anyway, when it comes up, we're going to find that what we're going to be working on today is defines and header files. And as before, make sure all this stuff gets filled in. And it talks about preprocessor directives. What are preprocessor directives? Anything that starts with a number sign, such as includes or preprocessor directives. What we're going to look at today are define statements. Now, we're going to set up basically what's here. And we can copy and paste this stuff, but we're going to put in a programmer's block to start because this is a very short assignment. Why is it a short assignment? Because typically I give you lab test 1 in the first period and ask you to do this in the second period, so it shouldn't take very much time at all. So here's what we're going to do. We're back over here. Let's go back and set up our normal stuff. Right mouse click, add new item, and we're going to call this lab 6A. And once it's in here, let's put in a very simple header. Let's put in Alt-Enter, or Shift-Alt-Enter, and let's go full screen. And back, whoops, /star. And title, program to illustrate number sign define statements. Okay. And author, now if we were smart, we would have actually grabbed all this information from the last one. And why didn't you think of it? Okay, I've got an excuse. I'm old and senile. And PRG 155 in your lab section. And today's date, well, my today's date is, let's see, June 9th. And 2009. Okay, description. Well, let's just put in the same thing. Let's not kill ourselves today and write books. So Control C, because we just wrote a lab test, chances are. So let's put in that. And that's good enough for today. // And let's see. Let's go back over here to our stuff. We've already got our include section. Let's see. Do we need an include section? Yep, we haven't got that yet. So let's grab that. Let's just grab all of this. Control C. Let's go back over here and Control V. Now, after we should put the title include section, so let's do that. And we should also put in what these includes are for. So we're going to say these have the definitions for printf, getchar or scanf, getchar, putstring, getstring, fflush. So that's what that is. Let's take a look here. These have the defines for getch, and this one here has the defines that are required for the system command. Now, notice what we've got here. We've got some interesting stuff going on. We've got number sign define, name, and then some quotes. Now I'm going to change these quotes because, as we know, the quotes aren't right. They have to be redone. Now, if you want to find out information about define statements to do this sort of thing, the text isn't really the best place. There's, I believe, at the end of notes for week 2, if you take a look at that PDF file, you should be able to find the information required to understand this. But I'll go through a little bit of this today. Now it says your name goes here. So I'm going to change that to my name, and this is what you should do. Change this to your name. And the street address, now I'm not going to come to your door and try and sell you anything, so let's use the college, 1750 Finch Avenue East. City, and for those people that don't know where they are, this happens to be North York when you're here. And not too many people know this next one. M2J2X5. So that's what we've got. Now notice we've got our main is not a proper main because we're going to have to do integer main, and we're going to have to do void. Now I've been sort of putting this off for a long period of time, and we'll get at this in a second. Let's also go back from full screen to regular screen so we can do our indent, increase indent, and let's go back to full screen again. And when we're back here, we do have to clean up this here. We're going to have to change this clear screen, change this. Now there was one thing that was missing in here. Notice we got name, address, city, postal, name, address. Whoops, we're missing city. So what I'm going to do is because there was a typo in this lab, and I do apologize for that. Let's just put this down. Address, city. Now, everything's pretty much ready to go. And the one thing that I was mentioning about integer main, if it's returning something, as it should, because this is a function. Main is a function, it's returning an integer, and the standard integer it should return is return and 0. So let's from now on put that in. We should have been doing this all the way along, but I've left it to now because this is a very short lab and we're sort of throwing a lot of extra stuff at you today. But let's see what this does. When it says define name, it says substitute for name exactly everything here, including the quotes. So what that means is that when you say number sign define, every time it sees NAME as capital letters, it's going to substitute exactly quote Dave Ross. Every time it sees address, it's going to put exactly this address, and so forth. So that's what it's going to do. So when you take a look down here, what the heck does this mean? Well, this means the same as put string quote Dave Ross. This means down here put string 1750 in quotes and so on. You don't believe me? Well, let's see that. Let's punch up F5 and see what happens. So it's compiling and all this kind of stuff. But let's see what it's going to do. Linking. This is fairly short. And we'll paste this stuff in so you can see exactly what's going on, as we've done before, and get an idea of what the heck these defines actually do. Now it just flashed, and the reason it flashed is we forgot one thing again, and that was to put in a get ch. So let's do that. Let's go back. Let's close this down a little bit and go down to the bottom before our return 0. And one of the things with returns is a return in a function has to be exactly the very last statement in that function, including main. So let's put in our get ch, and let's run it up one more time and see what happens. So it's going to do the compiling, linking, all this kind of stuff. So this time we'll be able to see our output and hold it on the screen. And there it is there. Now what we're going to do is right mouse click, edit, mark, and grab all this stuff, right mouse click, enter, and let's close this down here, and right after our code we're going to hit this /* control V and //. Now one of the things that you'll see here, and we talked about this before, is when it says put string name, it actually substitutes all of this for name. So it's like put string quote Dave Ross quote, put string address, put string quote this. So this is a great way of substituting stuff, and this is a very quick initial on your lab is to see this happening. So the whole concept of a define statement is it allows you to substitute for a label here anything you want as text. So that's the first part. So once you've got that done, and since this is a very short lab, maybe we can go through both parts and get both initials at the end. Let's see what we have to do in the second part. I was thinking, yeah, well, let's jump at that and get rid of it, but let me do one extra thing here. I want to show you why defines are so important, and you're looking at this and saying, what the heck am I doing this for? Well, let me show you something really interesting, because you're going to have to do one of these by the end of the semester. You're going to right mouse click. I'm just going to remove this for a second. And then what I'm going to do is I'm going to add, and I've got this under a bloodshed directory. We used to do bloodshed years ago, but let's take a look. On my C drive, I've got some old projects in here. So let me just take a look at, this is one we just did, I think, a semester or so ago. So let's bring that up and take a look. And notice, I'll go full screen here so you can see this a little better. Notice we've got a whole define section. GST amounts, PST amounts, Belgian waffles, all this kind of stuff. And let's see what this does. Notice we got Belgian waffles and syrup at $7.99, hot barbecue beef sandwich, and so on. So let's see what this does when we run it up. Okay, here we go. Now it's compiling and doing all this. Here we go. Wasn't that quick? Now notice Belgian waffles, $7.99. So every time I hit A on the keyboard, this is kind of cool. This is similar to the project you're going to be doing. Hit A, it does that. Hit B, it does that. Hit G, it does this. Hit R for reset, it does this. But notice what the current price is. Belgian waffles and syrup, $7.99. And so let's hit X to get out of this, and let's see how easy it is to change this by just changing a define statement. Let's call this French toast, and let's just space this over to here. So that's similar to the define that we did before in this current lab. And let's change the price because French toast, we're giving a bargain for recession special $1.45. Now when I run it up this time, watch what happens. Where it used to say Belgian waffles, it's going to say French toast and $1.45. See that? Every time you hit an A now, it's $1.45 every time instead of being the old price. So this gives programmers a lot of flexibility to change what their program does by changing some simple define statements. The price is changed. This is a great way to configure a program so that you can completely alter it any way you like. So that's why we're doing this. Not just because of your project, but because it's a great way to have programmers be more efficient. So think about it. If you're generating, let's just run this up one last time. If you're generating a restaurant menu and you're sitting on a beach somewhere down in the South Pacific or somewhere in the Caribbean, and somebody wants a change to their current menu, and they send you all the information, and you say, well, it's going to take me the better part of a day to do that, and it's going to cost you, maybe $100 or something. Well, really, what you're saying is it's going to take a day because you want to stay out on the beach and do something. How hard is it to do? You've seen how hard it is to do. You make a quick change here, you save it, you recompile it, you send it. It can be done in a matter of minutes. And you're saying take a day because you want to spend the whole day on the beach. So this is pretty cool. Anyway, let's get back to what we were working on and see, now that we know that this can be useful and save ourselves a lot of time and give us the ability to make money easily, let's see how we finish off this last part. Okay, if you've looked ahead at Lab 6B, it's practically identical to Lab 6A, and it's really just a revision. So when we want to do that, what we're going to do is say File, Save Lab 6A As. And if we do that, we can change this name down here from 6A to 6B, and then put in a .cpp and say Save. And you'll notice that nothing has really happened up here. This is still 6A. It's just saved a copy, but we want to work with that copy. So we're going to say remove this guy, and then right mouse click, add existing project or thing, and we're going to bring up 6B. So this way it's a complete duplicate of what we were just working on, and even down to this. So we're going to get rid of this because we want to put in our own output from that, and we don't want to cheat or anything. But once we've got this, we can always bring back 6A, which was this with the stuff pasted in. What we're going to do though is we're going to do some reworking here. Under source files as well, we're going to say add new item, and what we're going to do is we're going to go over here and go to header file this time. We're going to click on header file. We're going to go down here and change the name to be, as it says in the lab, my.def.h. And I've changed the location. Let's take a look down here. I've changed my location to make it right in the root directory because usually it's a couple directories down. So I've changed this by browsing. You can browse and put it right to the top level of your U drive. This will make what you're going to do next a little easier. If you don't, you're going to have to type in a little longer path, and that's fine as well. So I'm going to just say that's fine, and I'm going to add that in, and we're ready. So once I've done my browsing, you can see that it's mydef.h and f:\\. So I'm just going to go over here and do the add, and once I've done the add, you'll see that we've got two files showing up over here. Now, one of the things we found before is we can only have one CPP file and under the source section, but we can have as many .h files as we want, and this is our one H file that's going to go with this file because the two of them, we're really just taking a section out of 6B and putting it into the mydef file, so the two of them become a complete project. So let's take a look and see what we have to do. Let's go back to 6B, and as it says in here, and this is what we're going to do, we're just going to grab this information which is in our define section here. We're going to Control X, boop, and then double click on mydef and just Control V that in. And what we're going to do before we go back, we're going to say File, Save mydef.h. Okay? So that's saved that. Now we're going to go back to here, and we have to make an addition, and it tells you this in the lab, $ include. Now it depends where you put your code. Now you have to use double quotes. And notice up here, these aren't double quotes. Why aren't they double quotes? Because these definitions are in a standard place in the system that the system knows of. But we aren't putting it in those same standard places. We're putting it somewhere randomly on our drive. So what we're going to do is it says I'm going to put f:\\\, mydef.h, just as we had seen on that. Now if you've used a different path or a different U drive, then you're going to have to specify not only the U drive in your include. So you just say $include where all these defines were, and put f:\\mydef.h or u or e:, whatever, but put the exact path to where this file is. When you've done that, let's make sure we say file, save lab 6b. We've already saved the other one. Let's just punch up F5 and let's see, is it going to do exactly the same as we did before? Let's hope so. Cross your fingers and toes, because if it does, we're done. Yay! And except for copying and pasting this in. So when we run this up, and you're going to have to run this for your instructor, that yes indeed we get exactly the same output. So we're going to right mouse click, edit, mark, grab all this stuff as we did before, right mouse click, and then paste it in. So let's go down to the bottom of our file. We'll put /*, Control V this stuff in as before, //. Now it's very easy to fake this, as you saw, by just changing some stuff around and just copying this in and making some quick changes. So the instructor's not that stupid. They're going to get you to F5 this stuff to make sure it works on both versions. So you're going to have to unload and reload this to show the instructor that. So under source files, to go back, let's take a look at that. Right mouse click, remove, boom, yes, and remove both of these. And then we're going to reload to show the first one, existing item. Let's go to 6A and bring that up. And when you F5, that's what should happen. And you should be able to show that indeed you get this coming up as we did before. And since you don't have to reload the .h file, you can just remove this to show the instructor again. Remove this very quickly, right mouse click, add existing item, go up to 6b, and 6b, it actually knows where this code is because it's still saved on your drive. So you should be able to just do F5 and show indeed that this is what you're going to get is exactly the same output. When you show that to your lab instructor, you've got your two initials. Let's just verify that. Let's go back and take a look at our lab. And so all you have is a second initial here. You're done. You're out the door. And hopefully you did well in the lab test. And hopefully you got this done great. Next time, I keep screwing this up, but next time it's going to be lab 7. Have yourself a great day.